Now it's time to draw our first floor walls. Choose Floor 1 from the Navigation palette to make it the active layer. Then choose Show Snap Others from Layer Options drop-down menu in the palette. This layer option means you can see and snap to objects from other layers, but you cannot select or modify those objects in any way. We'll start by drawing the walls for the top left portion of this building. So zoom to the top left portion of the sketch using your mouse scroll wheel or the zoom tool in the basic tool palette. Then select the wall tool from the building shell toolset and make sure the first mode, left control line mode, is enabled in the toolbar. Additionally, choose the wall style Exterior CMU 10-inch plane from the Wall Styles drop-down menu in the toolbar. To start, click on the bottommost point of the angled wall that is connected to the stairs. Since we're using left control line mode, you'll want to click on the left side or outer surface of the walls. Don't forget you can use the snap loop to get the most accurate start point. Then, follow this wall by moving the cursor toward the vertical wall to the left. Notice the cursor cue 30 degrees is displayed. This is because we have Snap to Angle selected in the Snapping palette, and one of the default angles the cursor will snap to is 30 degrees. Once you have reached the intersection point, click once to set the point. Then, move the cursor upward toward the horizontal wall at the top. Once you reach the intersection point and cursor cue vertical is displayed, click to set the point. Next, move your cursor to the right along the horizontal wall until you reach the intersecting vertical wall. Then click once the cursor cue horizontal is shown. Now, trace this vertical wall until you reach the next intersecting wall, which is this angled wall that joins to the round wall. Click at that intersection point and follow the angled wall. Double-click at the intersection point of the round wall to finish. You should now see that all 5 of the walls were just created. Notice the Object Info palette also displays 5 walls, with the Wall tool still selected. Let's draw the remaining exterior walls in this selection. Click on the intersection point of the first wall we drew and the vertical wall that we have not yet traced. Now move your cursor vertically and click once on the horizontal wall above. When your wall's endpoint is connected with another wall, it only takes one click to finish the wall. Do the same to draw the remaining horizontal wall along with the 2 angled walls to the right. Okay, let's see how these walls look in 3D. From the View bar, enable Unified View and select Left Isometric from the Current View drop-down menu. At the moment, the walls have no height. To fix this, go to Edit, select All, and change the Top Bound drop-down menu to Layer Wall Height in the Object Info palette. Remember, we specified the layer wall height for the Floor 1 design layer earlier. Now, these walls' height will be determined by that value. Additionally, set the bottom bound drop-down menu to Layer Elevation. This means that the wall's Z height will be determined by the design layer's elevation. Next, we can return to a top plan view so that we can finish drawing the walls for this first floor plan. To start, we'll trace the 2 triangular-shaped walls on the right side of the plan. So just as before, select the Wall tool from the Building Shell toolset. Click on the intersection points for the walls until they are complete. Once those walls are complete, we can trace the walls in the bottom left portion of the plan. Trace the walls as shown. The interior walls in this bottom left section are thinner than the current wall style we're currently using, so we'll finish tracing the other walls before we get to these walls. To trace this circular wall in the middle of the plan, we need to switch to the Round Wall tool in the Building Shell toolset. Notice in the toolbar that the wall style is already set to the same wall style we chose with the Wall tool. so there's no need to make the selection again. But this time, we do need to choose the 3 points mode in the toolbar. Then, click on the topmost endpoint near the opening in the circular wall to begin creating the wall. Again, we are using the left control line mode, so you need to click on the outer surface or left side of the wall to start. Your next point can be anywhere along the left side of the circular wall, but for your last point, click on the bottommost endpoint near the opening in the circular wall to finish the wall. That's all for the exterior walls on the first floor. For the remaining interior walls, switch back to the Wall tool and click the Wall Preferences button in the toolbar. This will open the Wall Preferences dialog box. From the Wall Styles drop-down menu, choose Interior Metal Stud 3 5/8, Gypsum Board 5/8. Also, select the Insertion Options tab and change the top bound drop-down menu to Layer Wall Height and the bottom bound drop-down menu to Layer Elevation. Next, we can save the parameters we just set for this wall as a custom wall style by clicking the Save Preferences as Wall Style button. Name the wall style Aspen Interior Walls and click OK twice to return to the drawing. Now go ahead and trace the remaining interior walls. You can draw over the wall openings for now, as we'll add those later with the Door tool. Great, we've just finished our first floor walls. Let's go back to the left isometric view and see what we've got. Notice the exterior walls are still flat. Go to the Basic Tool palette and choose the Select Similar tool. Now, click on any one of the exterior walls, and all of the walls will be selected. Then, in the Object Info palette, change the top bound drop-down menu to Layer Wall Height, and change the bottom bound drop-down menu to Layer Elevation. You may first need to select Layer Elevation for the top bound drop-down menu, and then reselect Layer Wall Height in order to see the change. We still need to change the wall height for the round wall, so press the X key to switch back to the Selection tool. Click on the round wall and make the same changes to the top and bottom bound drop-down menus. We're looking pretty good, but these two selected straight walls that are supposed to meet the round wall are not joined. To fix this, select the Wall Join tool from the Building Shell toolset. Make sure the first mode, T-Join mode, is enabled, and click first on the straight wall, then on the round wall. You can see now that the walls will join properly. Do the same for the other straight wall that intersects with the round wall. And now let's see what the walls look like rendered. Go to the View bar and choose OpenGL from the Render Modes drop-down menu. Now use the Flyover tool to inspect your other walls. And then use Wall Join to join any walls that are not joined properly. Return to a top plan view once you're done. Now that the first floor walls are done, let's move on to the second floor walls. Before we create these walls, we'll need to create 2 new design layers and import 1 more PDF scan. First, go to Tools, Organization, and select Design Layer Floor 1. Then click the New button. This will create the new design layer above the previously highlighted layer. In the next dialog box, type Floor 2 in the Name field. You can also just click OK when the Edit Design Layers dialog box appears. We need to create 1 more design layer for the second floor scan. So first, highlight Design Layer Scan 1 and click the New button. Name the new layer Scan 2. This time, in the Edit Design Layers dialog box, set both the elevation field and the layer wall height field to 0 and click OK. With the new layers created, you can set design layers Scan 1 and Floor 1 to invisible. Also be sure Scan 2 is set as the active design layer. Click OK to close the dialog box. Now go to File, Import, and choose Import PDF. Select the file Scan2 from your exercise folder, then click Open and Import. As you can see, the PDF is much smaller than the PDF on Scan 1. To fix this, you'll need to perform the Scale Objects command. With the PDF selected, go to Modify, Scale Objects. The parameters you set from the first time should still be set, so all you need to do is uncheck the option Entire Drawing and click OK to scale the PDF to its proper size. Before we begin tracing the walls from this scan, we need to make sure it's aligned with the scan of the first floor. First, set Scan 1 to Visible from the navigation palette. Then, right-click Design Layer Scan 2 from the navigation palette and choose Edit. Drag the opacity slider to 50% and click OK. You should now be able to see Scan 1 below Scan 2. Now, using the Selection tool and the Snap Loop, align the second floor scan with the first floor plan. After getting the alignment as close as possible, zoom into the left corner of the second floor scan. With the PDF still selected, hold the Shift key while tapping the direction arrow to nudge the second floor until it exactly aligns with the first floor scan. Once complete, you can set design layers Scan 1 and Scan 2 to invisible. Additionally, set the opacity for Scan 2 back to 100%. Then, make Floor 1 the active layer from the navigation palette. We'll use the walls from this design layer to create the exterior walls for Floor 2. With the Selection tool, select the following walls. Be sure to hold the Shift key to select multiple objects. After you select the walls, go to Edit, Copy. Next, choose Floor 2 from the Active Layer menu in the View bar. Then go to Edit, Paste in Place. First, tap the X key twice to deselect the current walls. Then set Scan 2 to Visible briefly, and using the Selection tool, resize the angled wall in the top left portion of the plan so that it matches the floor scan. After resizing the wall, you can set Design Layer Scan 2 back to invisible. Now select the Wall Join tool from the Building Shell toolset and be sure the second mode, L-Join mode, is active in the toolbar. Then click on the walls in the same order as shown. With just a few clicks, we have all the exterior walls drawn for this floor. Set Design Layer Scan 2 back to Visible so that we can create the rest of the walls for this floor. Select the Wall tool from the Building Shell toolset and choose Aspen Interior Walls from the Wall Styles drop-down menu. Then, trace all the interior walls as shown. As you're tracing the walls, press the U key to cycle through the wall alignment modes in the toolbar to make tracing easier. Additionally, don't forget to use the Snap Loop to get a closer view when necessary. Here's what you should have once you're done. For the last set of walls in the lower left rooms, we need to use the Split tool and the Wall Join tool to create openings. First, we'll use the split tool in point split mode. Just click this wall twice, somewhere around these two areas. The wall is now split at these 2 points, leaving the resulting wall still selected. We don't need this portion, so press the delete key to remove it. Next, switch to the wall join tool and make sure L join mode is active in the toolbar. Then click on the walls in the same order as we're doing here. After this, you'll also need to switch to the X join mode in the toolbar and click on these walls in the same order shown here. For this wall, we'll use the Wall End Cap tool in Component Wrap mode to properly cap the wall. Click on one side of the wall, then on the other to create the wall end cap. Now, let's clean up the wall some before we move on. First, set the Scan To layer to Invisible in the navigation palette. If you look closely, you'll see that some wall breaks in these walls that are from the first floor walls do not apply here. So, select the Remove Wall Break tool from the Building Shell toolset and draw a marquee around these areas to remove the breaks. Next, let's take care of these wall joins by using the Wall Join tool in T mode. That's all for the second floor walls. Choose OpenGL from the Render Modes drop-down menu in the view bar. Now take a second using the Flyover tool to inspect the other walls and join any that are not joined properly with the Wall Join tool. Be sure to use the correct join mode. Additionally, if any of the walls are not the correct height, go to the Object Info palette and change the top bound drop-down menu to Layer Wall Height and the bottom bound drop-down menu to Layer Elevation. Once you have double-checked the walls, return to a top plane view. Just as you've done for the other floors, we need to create one more design layer for the foundation. Go to Tools, Organization, and first set Floor 2 to be invisible under the Design Layers tab. Also, make Floor 1 the active layer. Next, click the New button and name the new design layer Foundation. Make sure Edit Properties after creation is checked, then click OK. In the Edit Design Layers dialog box, set the elevation field to -6 feet and the layer wall height field to 72 inches. Also, change the stacking order field to 3. Once complete, click OK twice to return to the drawing. The design layer is set. Now you need to create the wall styles that will be used for the foundation walls. We'll begin with the foundation wall style. Select the Wall tool from the Building Shell toolset. Also, click the Wall Preferences button found in the toolbar. Then, choose Exterior CIP Concrete 12-inch -EIFS Imperial from the Wall Styles menu across the top of the Wall Preferences dialog box. In the Components section, delete the last components, LG metal framing and gypsum board. Additionally, switch to the Insertion Options tab and set the top bound drop-down menu to Layer Wall Height and the bottom bound drop-down menu to Layer Elevation. We'll also give this wall style a new class. To do this, choose New from the Class drop-down menu. In the New Class dialog box that appears, type Wall-Foundation into the name field and click OK. So that this custom wall style will be available for use later on, we need to save the wall style. To save the current wall style, just click the Save Preferences as Wall Style button and name the wall style. In this case, we'll name the wall style Exterior-CIP Concrete 12 inches -Foundation, then click OK. Now our wall foundation style is saved. Click OK to return to the drawing. Now we're ready to make the foundation walls. First, verify that Floor 1 is the active class in the navigation palette. Also, change the Layer Options drop-down menu to Active Only. This option means that only the objects on the active layer can be selected and modified. After setting the layer options, go to Edit, Select All to select all objects on Floor 1. Notice the Object Info palette displays 34 walls. Now, copy these selected walls by either going to Edit, Copy, or pressing Command-C on a Macintosh or Control-C on Windows. Next, set the design layer Foundation to be the active layer. Then go to Edit, Paste in Place. This will paste a copy of the walls on the foundation layer at the exact same coordinates as the walls on Floor 1. We don't need the interior walls shown in the bottom left area of the building. To easily remove these walls, tap the X key twice. Then select the Select Similar tool from the Basic Tool palette. Click the Preferences button in the toolbar and check the option for Class. Then click OK to return to the drawing area. Now, simply click on any one of these interior walls, and all of them will be selected. Adding that additional option in the Select Similar Preferences dialog box means that only walls in the same class would be highlighted, instead of all walls from any class. Again, notice the Object Info palette. It should now display 7 walls, all of which are assigned to the Wall Interior class. To remove these walls, simply press the Delete key. Next, press Command-A on a Macintosh or Control-A on Windows to select all of the remaining walls. Now from the Object Info palette, set the Class drop-down menu to Walls-Foundation. Although you have the walls set to the proper class, you still need to change the wall style to the foundation wall style we created earlier. At the moment, all of the walls should still be selected, so in the Object Info palette, choose Replace from the Style drop-down menu. From the Wall Replacement dialog box, choose Exterior-CIP Concrete 12-Foundation from the drop-down menu in the top right corner. Additionally, you'll need to select alignment for the current wall style in reference to the replacement wall style. For this instance, you can choose the component CMU 10 inches from the window on the left and component CIP Concrete from the window on the right. Also, choose Left Line for both wall styles and check Replace Height, Replace Class, and Replace Textures if they are not already checked. Then click OK to replace the current wall style. After replacing the wall style, we'll need to use the Wall Join tool in L-join mode to clean up some of the wall joins. As we've done previously, please click the walls in the same order as performed in this video to create the proper wall joins. We also need to resize a few of these walls, including resizing the round wall so that it's completely closed. With that, the foundation layer is complete. Now all that's left to do is create a footing for the building. The walls we've created for the foundation will be in the same place for the footing, but we'll need to use a different wall style. To begin, let's create the wall style needed for the footing. First, choose the Wall tool from the Building Shell toolset, and click the Wall Preferences button in the toolbar. Next, select Exterior-CIP Concrete 12-inch-Plane from the Wall Styles drop-down menu. Select the only component shown in the Components section and click the Edit button. Set the thickness field to 36 inches, then click OK. Switch to the Insertion Options tab. Set the top bound drop-down menu to Layer Wall Height and the bottom bound drop-down menu to Layer Elevation. Additionally, from the Class drop-down menu, choose New and name this class Wall-Footing. Uncheck Edit Properties after creation and click OK to return to the Wall Preferences dialog box. Last, click the Save Preferences as Wall Style button and name the wall style Exterior-CIP-Concrete 36 inches -footing and click OK twice to return to the drawing. Since the layout of the walls will basically remain the same as the foundation layer, we can simply duplicate that layer. To do this, go to the Design Layers tab in the Organization palette by clicking the Shortcut button in the View bar. Select the Foundation Design layer and click Duplicate. The new design layer should appear with the name Foundation-2. Select that design layer and click Edit. Change the name of this design layer to Footing. Also, set the Stacking Order field to 4. This will place the footing layer directly below the foundation layer. Additionally, input -7 feet in the elevation field and 1 foot in the layer wall height field. After making these changes, click OK twice to return to the drawing. At the moment, the foundation layer is the active design layer. Go to the Navigation palette and make the footing layer the active layer. Remember, the layer options are set to active only, so only the objects from the footing layer are showing, which are the exact same walls from the foundation layer, since we duplicated that layer. Now, we need to change the wall style for these walls to the correct type for a building footing. Just as you did for the foundation walls, go to Edit, select All, or use the keyboard shortcut command Command-A, Macintosh, or Control-A for Windows. In the Object Info palette, you should see there are 27 walls selected. Also, in the Object Info palette, go to the Style drop-down menu and choose Replace. When the Wall Replacement dialog box populates, choose Exterior-CIP Concrete 36-inch -footing from the drop-down in the top right corner of the dialog. Now select the CIP Concrete component for both walls in the Align section. You also need to select Center for the alignment of both styles, then click OK to change the wall style. Again, you can see when you make this change, we need to clean up these walls a little. First, we need to fix the joins where the short walls are overlapping. Let's start with the walls in the top right of the drawing first. Although it's difficult to see, there are 3 walls overlapping each other. Press the X key twice to switch to the Selection tool, and deselect the current selection. Select one of the 3 walls, then press the Delete key to remove it. Repeat this step again so that there is only 1 wall remaining. Now, select the wall that remains and go to the Object Info palette. Click the Polar Grid button at the bottom. Next, choose the center position point and change the angle field to 180 degrees. Now the wall should sit horizontally. Now let's fix the area with the overlapping walls toward the bottom of the building. Delete the 2 walls that are not joined to the adjacent horizontal wall. Then select the remaining wall and switch to the Polar Grid in the Object Info palette. This time, choose the leftmost position point and set the angle field to 90 degrees. The wall should now be perpendicular to the adjacent wall. You may need to rejoin this wall to the horizontal wall after performing this action with the Wall Join tool. Repeat these steps once for the overlapping walls toward the top center of the building, but set the angle field to 90 degrees. The last thing we need to do to finish cleaning up the footing walls is to use the Wall Join tool on any walls that are not properly joined. Once you're done cleaning up the joins, go to the Navigation palette and set the layer options back to Show, Snap, Modify Others, and make all layers visible except for the 2 scan layers. Now go to View, Unified View, if the option is not already checked. In a unified view, Vectorworks aligns all visible design layers in the drawing file with the active layer and stacks all layers in the Z direction according to their elevation values. To see this more clearly, switch to a right isometric view. Now let's take a second to render an OpenGL and use the flyover tool to see what we've got so far. When you're done, return to a top plan view.